All right, this skill is just to expand an expression. And all we're really doing is using the distributive property. So it looks like there's a lot of stuff to remember here, but really it's just the distributive property. If we have some quantity A times the sum of A plus B, we can distribute the A, right? We can distribute this first factor across this sum, all right? And we end up with this, A times B plus A times C, right? That's it. That's all you really have to remember. The rest of this is just special cases, just applications of the distributive property. All right. So if you remember one thing, it's just the distributive property. Now, the second thing that's listed here is the quantity B plus C times A. All we've done is swapped the B plus C with the A, but multiplication is commutative, meaning that we can multiply in any order, right? 3 times 4 is the same as 4 times 3. All right, so multiplication is commutative, so really this is the same thing. It's just that we've swapped the A and the B plus C. All right. Now, you may have learned in the past the acronym FOIL for multiplying two binomials. All right, so here we have two binomials. A binomial is just a factor with two terms. All right, so here we have two factors. We have a factor A plus B. We have a factor C plus D. And each one of those factors has two terms. All right, that's why it's called a binomial, right? This expression, this factor has two terms. And so bi meaning two, that's why it's called a binomial. All right, now you may have learned the acronym FOIL, which just means first, outer, inner, last. So we can multiply the first term of the first factor times the first term of the second factor, right? That's where the first comes from. We can multiply the outer two terms of the two factors, the inner two terms of the two factors, and then the last, all right? So you may have learned that kind of shortcut, but it's really just a distributive property. So here, let me erase this. Here it looks like the example I show is that we're taking this factor C plus D and distributing it across the first factor, the two terms in the first factor, and you can see where that FOIL acronym comes from. It's really just a special application of the distributive property. All right. And again, with these special cases down here, perfect squares, difference of two squares, negative of a binomial, these are all just applications of the distributive property. So here, with a perfect square, you're just taking A plus B times A plus B and foiling it, essentially. And you end up with A squared plus 2ab plus b squared. All right, so it's so that's just a special application. In the same way with the difference of two squares, the nice thing is that the outer and the inner terms, when you FOIL it, end up canceling each other out, and so you get this difference of two squares. If we have a negative of a binomial, again, we're just distributing that negative. You can think of that negative as being, times a -1, and so we're just distributing it, and that's it. So these are all of these are really just special cases of the distributive property. All right, so let's take a look at these examples. So this first one we have 2 times x squared plus 3. So I'm just going to distribute the 2 across the two terms in parentheses. Then we can remove the parentheses. So we get 2x squared plus 6. All right, so we've expanded that that expression and removed the grouping notation. All right, so here let's do the same thing. Here the first factor is the 7x, so we're going to distribute that across these two terms of this binomial. We'll end up with 14x squared, and then plus a 35x, and then we still have this -4 hanging on, and it's not in the parentheses, so we're not multiplying 7x times the -4, and that's it. There we go. We've done it. All right, now here we have this, the number out front is a 1/2, but again, we're just going to distribute that 1/2. So I'm going to take 1/2 times 4x, which is 2x, and then 1/2 times a -2, which is a -1. All right, so this one, I can actually rewrite this. I'm going to do this. I'm going to rewrite this as 1/3 times 6x cubed minus 3. All right, so I'm going to distribute that 1/3, right? So I'm basically dividing both terms by 3. So you get 1/3 times 6x cubed, you get 2x, oops, that's not x cubed, that's x squared, sorry. X squared, got a little distracted by the phone there. So we have 2x squared, and then 1/3 of -3 is a -1. All right, so remember that division is the same as multiplying by the reciprocal. All right, but we're dividing the whole thing by 3, right? This whole numerator by 3, so we have to multiply the whole numerator by the 1/3. All right, so this looks like a straightforward application of the FOIL, right? So I can do first, outer, inner, last, or I could take this whole term and multiply it times each one of the terms in the second binomial. But let's go ahead and use FOIL, right? So first, we're just going to multiply the first two terms of each binomial. So we'll get an x squared. And then outer, we get a -x, right? X times a -1 is -x. And then we'll add a 3x in the middle, right there with the inner terms. And then finally, 3 times a -1 is -3. All right. Now, whenever you use FOIL, you usually have a couple of terms you got to combine, right? If we want to simplify this, we need to combine those like terms. And so we have a -x plus 3x, which is a plus 2x, and then -3. All right. Here's another application of FOIL. So again, we're just going to take first, outer, inner, last. So we've got a 12x and 3x times 4. And then outer, we're going to have a -3x squared. And then inner, we're going to have a -20. And then finally, -5 times -x gives us a positive 5x. All right, so let's combine like terms here. And typically when we have a polynomial, we usually write the powers of x in descending order. So I'm actually going to write the -3x squared first. And then I have two x terms. So I have a 12x and I have a 5x, which combines to be 17x. And then finally the -20. All right, so that would be the simplest form that we could get it into. All right, now this one looks a lot like the other one, except there's some parentheses missing, right? We have 3x and then -5 times the quantity 4 minus x. All right, so be careful. Those parentheses make a big difference because this is going to give us a different answer than the previous problem. Even though they look very similar, those parentheses make a huge difference. So here we're only taking the -5 times the two terms in the binomial. And so we're not doing anything with this 3x. So we have 3x, and then we're going to distribute the -5. You know, you can think of this as a plus a -5, and then we're going to distribute the -5. So we're going to have a -20, right? And then I take -5 times -x, and I'm going to get a positive 5x. All right, now we need to combine like terms. I have a 3x and a 5x, and I get an 8x and then -20. All right, so just be careful. Parentheses matter. Parentheses matter. All right, so you can see that when we have the quantity 3x minus 5 times the quantity 4 minus x, that's different than 3x minus 5 times the quantity 4 minus x. Okay, you don't get the same answer, even though they look very similar. So, all right. Now here, if we were to go back up to the reference, you know, you could see that we have a difference of two squares here. All right, we have an x minus 1 and an x plus 1. But you don't have to remember that. We can just FOIL this out, and we'll end up with x squared, and then we have a minus x, and then a plus x, and then minus 1, right, when we FOIL that out. And those two middle terms end up canceling. We have minus x plus x just becomes 0. And so we have x squared minus 1. That's where the difference of two squares comes in. All right. So you don't have to remember, if you're trying to expand an expression, you don't have to remember the difference of two squares. You'll see when we factor an expression, it's helpful to remember what the difference of two squares factors into, but we're not there yet. We're just expanding expressions right now. All right, these last two. All right, so we have 3x squared, right? So there's nothing there. Nothing we have to do to that one. But we've got minus this whole quantity, x squared minus 2x minus 3. So we have to remember to distribute the minus across all of this. This is essentially like a minus 1 times all of that. All right, so I'm going to take negative 1 times each one of the terms in that are in parentheses there. So I'm going to get a minus x squared, and then I take it negative 1 times this negative 2x. I get a plus 2x, and then negative 1 times negative 3 becomes a plus 3. Okay, now to simplify, we just need to combine like terms. And so it looks like we have a couple of x squared terms there. So 3x squared minus x squared becomes a 2x squared, and then plus 2x plus 3. All right, last one. So here we're squaring this x minus 5. And just remember that that just means x minus 5 times x minus 5. All right, so you can just FOIL it. You can use the distributive property on it. And so if I FOIL that out, I'm going to get x squared, and then I have a minus 5x, right? I have x times the minus 5, and then I have another minus 5 times x, so I'm going to have another minus 5x, and then the last two terms become a positive 25. And then we'll combine the terms in the middle and get a negative 10x plus 25, okay? So you can remember the form of a perfect square, and just remember the middle term is first times last times 2, or you could just FOIL it out and get the answer. All right, that's all I got. I'll see you in class.